let me quickly recap, or sort not recap, actually, let me quickly finish what we have started in the presentation. So what we were discussing is what we were discussing about the 7 concepts of total quality management earlier, and continuous improvement is all. So let me focus on few. The continuous improvement, as I have told you, that is the never-ending process of continuous improvement, and it encompasses not only people, equipment, materials, and all the procedures that are involved in manufacturing the product or providing the services. Each and every one should be continuously improved. And the basic idea behind this is every operation can definitely improve, and you have to follow a cycle known as PDCA cycle. What is this PDCA cycle? PDCA cycle is nothing but plan, do, check, and act. Number one, the very first step, if you want continuous improvement, is identify the pattern and make a plan. How will you improve the process? How will the process should be improved? What are the defects and the problems in the process? Once you plan that, then you actually do that. Whatever we have planned on papers, you try to implement that in real scenario. You test your plan, whether the plan will work or not. If you believe the plan will work, then what you do, you basically implement that plan, and then you, after implementing that plan, you check whether the plan that you have implemented is working as per your intentions, as per your planning. Whatever you have planned earlier, that the process should be working in such and such way, whether the process is actually working in that way or not. And if you believe that the process is working, you have to, or the process needs some further improvement, you need to act accordingly. And acting means again going for the plan, again checking it, again doing it, checking it, and acting as per the desired planning. So this is a PDCA cycle. You plan, you do, you check, and you act. So that's a continuous cycle. You can see arrowheads, and these arrowheads actually tells you that it's a continuous improvement in the process. It actually calls for continuous improvement. So another concept of continuous improvement that we know of is known as Kaizen. Kaizen is a Japanese term. It actually means ongoing improvement or ongoing continuous improvement. You have to strive each and every day, each and every time to improve the quality of the system. Quality cannot be achieved 100%. You have to continuously strive for achieving the quality. That's known as Kaizen system. Total quality management, zero defect system, they all describe the continuous improvement. Total quality management, हम आगे भी देखेंगे. There are different tools how to achieve this continuous improvement, but these tools are not in your course. You can those who will choose total quality management as a subject in the next year, they will understand that how there are different tools of total quality management which actually helps in continuous improvement. And finally, the zero defect system. Do right the first time, and the process should actually result in zero defects. So this is the concept of continuous improvement. Continuously improve the process. You don't have to stop. You cannot achieve quality 100% right the first time. You have to continuously improve that. There may be technological advancements. You need to focus on that as well. There may be competitions. You need to focus on that as well. Then comes the next concept of Six Sigma. As you have seen that we have seen the case study of Mumbai Dabbawalas, and they are Six Sigma approved, and they have Six Sigma with them, ISO certifications with them. What is the Six Sigma? It means 3.4 defects per million opportunities. Means आपने first year में quantitative techniques से पढ़ा होगा. This bell curve, you must have seen this bell curve. ऐसा तो नहीं किसी ने देखा ये bell curve क्या है? You must have seen that, right? तो bell curve का एक area होता है. 1 sigma, 2 sigma, 3 sigma. On the right hand side, 1 sigma, 2 sigma, 3 sigma on the left hand side. तो जब हम combine करते हैं किसी भी process को, तो our idea is that the majority of process should be in control and produce the desired output. क्या मतलब? It should be producing the quality product the very first time. And in 1 million product, if you have 3.4 defects in 1 million product, why you people are interested in writing the attendance? I don't know why. If you are interested in attendance only, you may leave the meeting now. Every time the chat window pops up and I am actually looking at the chat, what somebody is asking a question or not, you're just writing your attendance. If attendance is the only factor you have written down to attendance, you are requested to leave the meeting. Please leave the meeting. Mohit, Keshu, Aman, Muzammil Sahab and Abdul Wahab Sahab. You are requested to leave the meeting now. Your attendance has been noted.
Sorry, sir.
So the basic idea is, if in the process, if you're producing 1 million products, and out of those 1 million products, only 3.4 of them are defective products. It means you are having the limits of 6 sigma. 6 sigma का आप जैसे एरिया देख रहे हैं, you can find this 3.4 per million products. ये जो boundaries आप देख रहे हैं on the left and right hand side, it means ये इसके अंदर की जो भी area होगा, it is producing the good result, and beyond these limits, you are producing a defective product. So, अगर हम बात करते हैं 6 sigma की, the basic idea is 99.997% the system is actually producing a very good result or quality result or intended results. So this 6 sigma का concept or detail में you will find in the next semester. But the basic idea is that this process, if you want to achieve 6 sigma, you have to continuously improve your process, and you may improve the process from 2 sigma to 4 sigma, then 6 sigma. Means you have to understand that you need to increase the boundary of your quality products. जितनी ज़्यादा आपके left hand side और right hand side पे जितने extreme पे आप चलते चले जाएंगे, you are actually trying to produce quality products, and within those limits, the product is a quality product. So कहीं ना कहीं आकर what you are doing, you are actually improving the quality continuously, and the result is that you have only 3.4 defective items per million of the products. So this is the concept of 6 sigma. We can discuss this concept because of paucity of time. I usually have different case studies on 6 sigma as well, but unfortunately because of paucity of time, we will not focus on that. But the 6 sigma is actually a very important approach if you want to improve the quality, if you want to improve the process. अब डब्बा वाला केस हमने डिस्कस कर रहा, what has happened in डब्बा वाला is actually not producing any product. They are providing the service, and in that service they are 99.99997 times perfect. You don't have they don't have defective products in there, the defective services in there. It is so that is why they have 6 sigma certification with them. A very important approach of actually 6 sigma certification is not for lifetime, because you might fail in your process in coming times. There's a particular timeline for that. You have to again and again revisit and again recertify yourself for 6 sigma. Similarly with other standards like ISO, etc., they have committees. They come to the facility, they look at the process, and they finally decide whether you will be again getting the certification or not. So it's not for a lifetime, of course. So 6 sigma have a DMAIC approach. This approach is actually help you in achieving 6 sigma. The very first thing is defining what is your purpose, what quality you want to achieve. You need to have a proper definition of that. What is the scope, what output you desire. You have to define everything. First, you need to define that how you will achieve the quality, what quality is meant for you, what quality is meant for your customer, how will you achieve that. Define everything in clear terms. Then you have to define the measurement. How will you measure that, whether the product is actually providing you the quality that is desired, there should be set standards, set measures. For example, अगर मैं कहता हूँ कि मैं battery manufacturer हूँ and my lifetime of battery is, let's say, of a mobile phone, let's say, is for 1 to 2 years. So I should be able to measure that, means in terms of volt, in terms of battery capability, in terms of ohms, amperes, etc. So there will be some measuring process that you will actually measure that what type of product I am producing and what is the quality that you are actually trying to achieve. Once you set the standards for measurement, you analyze whether that product I am producing is as per my definition or as per the measurement that I am trying to achieve. You analyze that. And you analyze and then you go for improvement. Of course, there is no such thing as 100% quality. It's a continuous process. You have to improve your process. You have to sometimes modify the process. You have to sometimes redesign your process to achieve better quality. Our battery की बात मैंने करी. You must have seen batteries of older phones. पुराने मोबाइल फोन्स अगर आप देखेंगे, you may find the size, the height, the depth, the weight of the mobile phones completely different with the mobile phone that we have today. That's a continuous improvement of quality. You're modifying, you're redesigning everything. Cameras today, as you can see, that majority of players are now having 2, 3 cameras at the back and one front camera. The front camera is also more than 16 megapixels or 48 megapixels in some mobile phones. What you are doing, you're continuously modifying, you're continuously redesigning the process, you're improving the process so that ultimately the customer needs can be met. And once you do that, you also control the process. Whatever you have defined, whatever you are measuring, whatever you are analyzing, whatever your improvement you are making, that should be under control. You cannot let the process work on its, out of control. And that is why Six Sigma is very important. And that is why this DAIC approach is actually what we know as, Six Sigma. Next important is employee empowerment. You need to understand that whatever employees who are involved in the process should also be trained enough, should also be given responsibilities so that they will maintain the quality themselves. They don't have to seek permission of the top management each and every time. They have to ultimately come together and work as a quality person, himself or herself. So whosoever with the employee in the organization, they should get involved in the product processes, and they should also suggest that what type of suggestions will actually help in improvement of the process. This is also one of the approach of one of the managers, that those employees who are working on the process are the best judge whether the process is in control, whether the process is actually producing the results, desired results or not. So employee empowerment is very important if you are talking about total quality management. And based on that, there are quality teams, there are quality circles. Means employees who are regularly meeting and resolving the problem on their own. If the one process is not working in, for example, production, the quality circles will be there. They come together, they analyze the process and they plan, they give solutions on how to improve the process, how to improve the quality, how to reduce the waste, etc. And then they will implement. So no top management is involved, only the employees who are working on the process are involved. So that is what we know as quality circles. The details will be followed up in the next semesters, coming semesters, those who are out for quality management. So quality teams, quality circles are very much important because you can solve the problem then and there. You don't have to ask for each and every time from the top management. You may find something which is not going on as per the standards. You may improve the process. You may improve the whole process on your own. The quality teams will settle down. They will decide how to improve that, and ultimately improvement will be done. Another important concept of TQM is benchmarking. You need to understand that you need to set some standards, that this is my process, this is going on, and this is the industry leader. The industry leader's process is actually resulting in this type of product. So industry leader जो आप देखते हैं, you determine that industry leader or determine the process of that leader, and you set a benchmark for your team. That is the benchmark that I need to achieve. That is the efficiency that I need to achieve in my organization. So that is known as benchmarking. You actually determine, first of all, what process you need to benchmark. You form a benchmarking team. You identify your partners that will help you in benchmarking. You analyze the information and you actually try to achieve the benchmarking line, the benchmarking approach. So one of the important approach of benchmarking is data envelopment analysis. That is not in your course, but it has been widely used in industry. What happening? This is the process which is giving you this much of result. For example, a process of bottling manufacturing, bottle manufacturers are resulting in 1,000 bottles in an hour, but the market leader is producing 1,500 bottles in an hour. That is a benchmark. Your basic idea is to achieve that 1,500 bottles per hour benchmark. So this is also very important. And because of benchmarking, now your focus is improvement, and then you form a team, then you go for form quality circles, then you actually go for continuous improvement, and ultimately total quality management practices are been implemented. Just in time, because some just-in-time concept is a Japanese concept, because Japan is a waterlogged nation, waterlogged country that have been everywhere. There's water everywhere, so they're very limited space. So what they do basically, they cut short on spaces, and warehouse की space की बात करें हम, या raw material की storage की बात करें हम, they don't focus on that. They say that whenever the material is required for the process, it should be available at that particular time. You don't have to store that process. You store that raw material in a warehouse. That process should reach us then and there. So it ultimately improve in better inventory management techniques. And because of better management techniques, the overall quality of the system improves. The overall cost reduces. The profitability increases. Just-in-time process is very, very good process, but it's more of a theoretical process, because you cannot have every time that you may have different lead times. You may have different other problems in the system that may impact your overall inventory management techniques. But yes, just-in-time is very much achievable. Few companies in Japan have done that. You have Taguchi concepts. Taguchi concept, तो हम चलो next class में बात कर लेंगे. Let me cut short it to tools. हम next class में will discuss about Taguchi concept because it needs some time. Taguchi concept from we'll discuss in the next class. But TQM tools की बात हम करें, there are different tools of TQM, and where these tools have been applied and been used by organizations practically to understand whether the process or whether the quality improvement has been done or not. So there are different tools for generating ideas. How you can generate ideas of quality improvement, like check sheets, scatter diagram, cause and effect diagram. You have tools to organize the data, like Pareto charts, flow charts, process diagrams. We will discuss this one by one in a little detail in the next class. And then you have TQM tools, who actually are there to identify the problem, and then after identification of the problem, you can remove those problems. So the histogram and statistical process control charts are two tools that have been used widely in organizations to actually identify whether the process is in control or not, whether my system is in control or not. If the system is out of control, you have to find the reasons for that, and then you actually try to work out and removing those reasons so that the overall process should be improved. So if there any query, you are most welcome to ask, and you are requested to write down your attendance in the chat box, please.
Sir, I have a question regarding the 6 Sigma.
Yes, sir. Yes, Kishu.
Sir, basically, in that we saw that whenever the quantity got increased, suddenly the effective quantity also increased, and after a certain time, it eventually the effectiveness of the material gets reduced, and the quality gets improved simultaneously. So, is it having some specific quantity for the sigma when we are talking about the 3 sigma, 6 sigma? Does sigma has any quantity, or it is some?
Actually, if I am able to get your question correctly, Keshu, you are asking that if you talk about 6 sigma, do we have a quantity in mind? Do we have some quantity, and whether that quantity will be, if we improve the quantity, then ultimately the defects will decrease, right? This is what you are asking?
No, sir. Basically, it is in respect of the certain quantity, or it is just to tell that it is happened from that diagram. Basically, I'm saying sigma has some value in that diagram or something.
Okay. So you are asking that you need to produce 1 million products to understand whether your process is following Six Sigma or not, right?
Yes, sir.
No, you don't have to have 1 million products. Whatever products you are producing, during the production of the process, what are the rate of waste or rate of rejection or the rate of defective products? So, for example, if I'm producing only, let's suppose, 50,000 products in a year, right? And how to get Six Sigma approach then? Whether how to achieve Six Sigma then, right? That is your question. Because if you are asking Six Sigma, the standard shows that it is defects 3 point something defects per million products, right? So if those 50,000 products fall under the defective products, it falls under the range of that particular limit only. Means if you're talking about 1 million defects, and if you talk about this, how much was that? 3.11. Yes, 3.4 defects per million. So if you are producing 500,000 products, that defects will reduce to 1.7. If you are producing 250,000 products, the defects should actually go down. So what if you are not producing million products, it will definitely cut down to the ratio or that whether you are able to produce it or not. And Six Sigma is actually more towards the process, whether the process that you are using is producing the quality results or not. It is not actually directly related to the product. It is also related to the process that has been involved. So if you're producing, let's say 50,000 products and you have a one product out of 50,000 that is actually a defective product, you may not be able to achieve Six Sigma, because ultimately it will, if you multiply 50,000 and you will want to achieve 10 lakhs, it may become more than 3. The whole process might not result in Six Sigma certification. What they will ask that if you are producing in an year 50,000, so in 10 years, you will be able to produce 5 lakhs. That's 500,000. If in 500,000, whether you have 1.7 defects or not. I hope I am able to convey my answer.
Yes, sir. Thank you so much.
Okay. Any other question? So if you don't have any other question, you are requested to kindly log off the meeting, and we will have a class tomorrow at 9:20, I suppose. Then we will be discussing this remaining concept of Taguchi and other TQM tools, and then we will be focusing on statistical quality control. That's a very important topic, and we may require, an extra class on Sundays or Sunday at this time to actually help you understand that the concept of statistical process control. Asif sir will be taking that, and of course I will be available as well. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.